start this now. As you all know my name is Dilpreet Kaur. I am your maths teacher and I have a total of 5+ years of online teaching experience and mentored so many students. Okay, let's move forward now. And we are doing real numbers, as you all know. Real numbers, a chapter that we have started, and we are done with 2 classes, and this is the 3rd lecture of successive magnification. Okay, so by successive magnification, I always start with the name first. Okay, with successive magnification, I just want that. Do you understand something with the name? Everyone, just give me a thumbs up or hands up if you understand something with the name. Okay, so I can see from school 1 and school 2. Yes, great. So successive magnification, successive means like one after another, and magnification means like when we are very small, I used to have a magnifying lens. So I hope you all, maybe that you all have that too. So I used to magnify each and everything in front of me. So in that magnification, we are doing the exact magnification that we understood. Let's move forward. Let's see what successive magnification in real numbers means. Okay, moving forward. And what we have, the chapter roadmap. Everybody knows that we are done with introduction to rational numbers. Okay, then we have done irrational numbers. Now we are here. Okay, that's me and you all guys. Okay, so we are doing successive magnification here. Now after that will be like doing rationalization, exponents, inserts, and an amazing session based on super practice session. Let's move forward now. And last class, what we did, we learned about decimal representation, terminating and non-terminating, and you all helped me in solving some of the questions, right? Do you remember, everyone? Do you remember the questions, the concepts from the last class? Everybody revise this thing kindly. Okay, can I see some hands from school 1, school 2? Do you remember the last lecture? Okay, so people are still in low energy today. Okay, so in questions, let's see how will you perform. Now expressing decimal in PQ form, P over Q form, that we also have did in the last section, last lecture. Now in that lecture, we started irrational numbers. We did the definition. We find irrational numbers between 2 numbers, and we did operations on irrational numbers. So one topic was left from the last session. We are continuing with that thing in today's lecture. Okay. So there is a question for you all. Everybody attentive? Have your notebooks and your pens ready? So this is a question, and these are the options you have. Let's see which school will answer fast, and I'll ask any one of you. So whosoever is done the question, kindly raise your hand or you can speak in front.
bar. 0.375.
So there is a bar on the top, 0.375 bar.
What will be the answer?
This is the concept from last class. Yes, who did the question? Okay, from school 1 somebody is answering. Okay, somebody said A. And from school 2? Anyone has completed? Kindly speak, your voice is not audible. Yes. A? D, you are saying D. Okay. Okay, 4, na? Right, 4. Okay, so school 2 has answered 2, the D option, and school 1 has answered A. So let's see which answer is correct. Okay, A option is correct. So I just want to make you remember, do you know what bar means? So school 1, whose answer is A, that is the correct answer. Other than A, all answers are wrong. Okay, I am just revising you. Make you revise that 0.375 bar is like this. Okay, school 2, kindly listen. So this number, it is equal to 0.375, 375, 375, and so on. Okay, so do you remember this question? How we used to did this question? So we just take this question as 1 and we name it as 0.375, 375, and so on as first equation. Then we used to multiply by 1000 because the periodicity, it is 3. The periodicity is 375 bar. So let me change my pen. Okay, so what I get here, I get this thing. Dot, dot, dot. This is my equation 2. So equation 1 you understood. Equation 2 is this when I multiply with 1000 on the left hand side and on the right hand side. Now I have to subtract equation 1 from equation 2. So what I get here is, I get 999 x, it is equal to 375. And x will be equal to 375 by 999. So this is option A. As you can see here, I have given you, I think, around 1 minute. This is not a question that has to be done in 1 minute. It is a 30-second question. Okay, so this was the topic from last lecture. So I hope who do not understand, like they understood now, and you can revise the last lecture also. So this was a basic question of irrational numbers. Do you get, everybody, school 2? Are you able to understand? Okay, can you put your thumbs little higher because like I cannot see? Yes, great. Now I can see them. Okay, so first question is done. So I think you have learned something here. Now let's move on to the second question. So irrational number between 5.5 and 5.7. Just listen to the question carefully and answer to me. Okay. So these are the options. This is the question.
Option D, ma'am.
Okay, school 2 has said option D. What about school 1?
Yeah.
Can you repeat school 1?
Yeah.
Okay, you are again saying D. Okay, let's see the options now. Let's see the answer now. Okay, great. So you all remember the definition of irrational numbers, 5.5 and 5.7. We have to find a rational number between these. So starting from 5.6, it could be any number. Okay, now 5.6214536 and so on. It is a irrational number between 5.5 and 5.7. Okay, now 5.5 something, it is also an irrational number. 5.6 something, it is also an irrational number. Can you tell me that is this an irrational number between these two numbers? I just want to ask first boy in school 1 that is sitting in front of me. Like, can you hold the mic and tell me, is this a rational number between 5.5 and 5.7? The teacher, can you please help me, that kindly hand over him the mic, or he can like stand up and tell me in the front, like just walk front of the laptop and you can say,
Madam.
Is this a irrational number between 5.5 and 5.7?
No, madam.
No, na? Why? Can you tell me why? Why this is not an irrational number? I am not able to listen. Okay, you can just sit down. You said that no, it is not an irrational number between 5.5 and 5.7. Let me tell you the reason, because this is a recurring. It is 5.69 bar. This is not irrational. Okay, this is not irrational. If I have written this in the options, that will not be the answer. 5.696969 is not the answer, because it is not irrational. We have to find irrational, right? So I hope all the questions are clear till now, and we are moving to our today's topic. Let's start this now. What will we learn in today's class? The leftover topic from the last class, that is representation on number line. We are doing irrational numbers, right? So after that, we'll be jumping on real numbers, some definitions, some results, and after that, we'll be doing successive magnification. Okay, let's start now. Irrational numbers. Do you remember? I just told you in the last lecture, a negative of an irrational number is an irrational number. So if root 2 is irrational, then so is minus root 2. If root 5 is irrational, then so is minus root 5. If pi is irrational, then so is minus pi. Clear, everyone? Okay. So if I can see you moving here and there, na, so I thought that you are not like comfortably sit, or you are not understanding. So just like focus on the class here, okay? Let's move forward. This is the first result, okay, from the last class. Now the second one is the sum, difference, product, and quotient of any non-zero rational number and an irrational number is an irrational number. Okay, now we are talking about sum, difference, product, and quotient of any non-zero rational and irrational, which means 2 plus root 5. This is irrational. 5 minus root 7. This is irrational. 6 root 11. This is irrational. And 5 over root 3. This is irrational. So this is the result, which is result number 2. Okay, understood everyone? Just keep your hands up if you understood. Okay, school 2. Okay, great. Now, what about result 3? The sum, difference, product, and quotient of two irrational numbers. Can you see the difference? Here there is one rational and one irrational. Here two irrational numbers. They may be irrational, they may be rational. So we have did the examples. That is 5 plus root 3 irrational, plus 5 minus root 3 irrational. But the sum is 10. It is rational. Okay, in similar way, 5 plus root 3, 2 minus root 5. This is 7 plus root 3 minus root 5. Irrational. So I hope you understood this. The sum of two irrational number, it could be rational or irrational. Everyone clear of these results? Okay, great. Now, moving ahead. Now in irrational numbers, we want to represent these such numbers on the number line. Okay, so here what are we following? We are following Pythagoras theorem. Everybody know here that what Pythagoras theorem means? Okay, so in school 2, in the first line to the extreme left of me. So can you raise your hand? Yes, yes. Kindly give her the mic. Yes, yes, you are giving. Yes. So can you tell me what Pythagoras theorem means? Do not hesitate, just whatever comes in your mind. Pythagoras theorem, I think we learned that in triangles, right? So do you remember anything regarding Pythagoras theorem? I'm not able to understand. Okay, so do you know anything about Pythagoras? Yes or no? You said yes? Okay, so you can sit down. So let me tell you about Pythagoras theorem. Pythagoras theorem is exactly based on triangles, and you can sit down. You can sit down now. Okay, majorly on right angle triangles. Can you see here? This is a right angle triangle, and this is A, this is B, this is C. Okay, these are the sides of right angle triangle. What does Pythagoras theorem mean? If AC, I'll name it as H. BC, the length of BC, it is B. And the length of AB, it is equal to L. Okay, or we can say P. Now, what is Pythagoras theorem? It says H square, it is equal to P square plus B square. This is Pythagoras theorem. It is just the square of the largest side. It is equal to the sum of the squares of two other sides. Clear, everyone? This is the simplest approach that we are using. We are just using this formula in this procedure. Out of Pythagoras theorem, we are just using this formula. That is, the largest side whole square, it is equal to the sum of squares of the other sides. Do you understand, school 2? Do you understand? Okay, school 1? Okay. So we'll be using this Pythagoras theorem in the representation of irrational numbers. Okay. So can you tell me, anyone, if I have root 2 as my hypotenuse, this is known as the largest side and it is known as hypotenuse. If root 2 is my hypotenuse, what are the chances that what will be the base and the perpendicular? This is base, this is perpendicular. Can you tell me the length of base or perpendicular if I have hypotenuse as root 2? 1, yes. Whosoever answered, 1 is the correct answer. So if base is 1 and perpendicular is 1, let us put this in this, okay, in the formula. Let's see. So if I have 1 square and 1 square, I get 1. That is equal to 2. And h is equal to root 2. Clear? So we get root 2 as the hypotenuse if I have base as 1 and perpendicular as 1. Okay. So for the representation of root 2 on the number line, we just need to plot 1 unit on the number line and we have a perpendicular distance 1 unit on the number line. Let's see. Okay. I have to erase something. Okay. You can see from here. Everybody understood about how we take 1 and 1? Okay. So can you see this? This is a right angle triangle. What we did, this is a number line. On the number line, we have taken OA as 1 unit. And we have taken a perpendicular distance that is also equal to 1 unit. And we all know that using Pythagoras theorem, that is root 2, it is equal to 1 square plus 1 square under the root. Okay. So this thing, we get this thing from Pythagoras theorem, and root 2 will be the hypotenuse. Root 2 will be the hypotenuse. Now to represent root 2 on the number line, it is still not on the number line, it is on the triangle. We get root 2, but it is on the triangle. We have to put this OB on number line. So what we'll do, we'll put our compass on O and the pencil on B. We'll stretch our compass like this on OB and put an arc on the number line like this. Okay. So this will be our C and this total will be equal to root 2 units. Now OC is on the number line and that is equal to root 2 units. Now we have just represented root 2, that is an irrational number, on the number line. Any doubt in this thing? So are we clear about the how we have chosen 1 and 1 and how we have put root 2 on the number line? School 1, is that clear? School 2? No, I cannot hear. It's like, yes, ma'am.
Yes, ma'am.
Great. This is the energy I wanted. So here what we have done, we have just plotted root 2 on the number line. Let's move further and let us revise this. Okay. Let's see from on other irrational number, does this work? So in the next, that is representing root 3 on the number line. Now for representing root 3 on the number line, can anyone tell me that what would be, like, this is the triangle, okay? If I want this to be root 3, what will be the measure of base and the perpendicular? Any guesses will work, okay? Can you tell me, anyone from school 1? The formula is p square. It is equal to h square plus b square. It's, sorry, h square. My mistake. It's p square. Can anyone from school 1 tell me that what can be the, what can you guess something, that what could be the base, what could be the height? Okay, school 2, somebody is answering.
తీసుకో సిద్ధార్థ టేక్ మాట్లాడు చెప్పు
Yes, you can answer.
స్టాండ్ అప్ బాయ్
1.5.
I'm not able to listen.
1.5.
1.5. Okay, so let me write this here, 1.5. Okay, so I just want to put 1.5 in this and I have to guess the base also, so that I can get h as root 3. I think it is not possible. You have taken 3 by 2, right? This is equal to 3 by 2. So you are saying that 3 by 2, 3 by 2 will make root 3. Okay, let me tell you one thing. If I'll take root 2 as the base and again 1 as the perpendicular distance. Okay, so let's see, will this work or not? I'll put p as 1. Okay, then b as root 2. I'll be getting 1 plus 2, that is equal to 3. So h square is equal to 3. This will give me h as root 3. Do you understand this? I am just using the previous concept. I know how to plot root 2 on the number line. So I'll try to use that thing. And as you know that we are drawing a perpendicular distance on the number line. So it is easy to just draw 1 unit. It is easy to draw just 1 unit here and we'll solve like this. We get the hypotenuse as root 3 and we will plot that on the number line. Let's see how this works. So what we have here, we have this from the previous diagram, right? We have this from the previous diagram. So what we did, we use a compass and we plot OC as root 2. Right? Now what we need here, we need base as root 2. So if I take OC, my base, and if I just draw 1 unit here on C, can you focus on this triangle that has OC as base, and let me give this a name. It is D. Okay, CD as the perpendicular. Can you see that? Now if I will join OD, what will I get? If I join OD, what will I get from school 2? Anyone can answer? What will be the hypotenuse if I'll join this? See, any boy from school 2 can answer what will be the length of OD. I think their voice is not coming if somebody is speaking. Ma'am, can you help? It is just a one word answer. You can say it on mic or you can say in front of the laptop. Okay, from school 1, somebody is raising hand. Yes, you can answer. Root 3. Okay, so somebody has said OD is equal to root 3. So are you all clear? So sorry for the inconvenience. Okay, so we get that OD is equal to root 3 units. Everybody does, everybody get that, right? Now we will put the compass on O and take OD as radius and we will put it like this. We will put an arc on the number line. So this will be OG. OG will be root 3 units on the number line. OG will be equal to root 3 units on the number line. So I hope you understood the phenomena, how the concept works, how the Pythagoras theorem works here. We are just wanting the base as much long as it is and the perpendicular could be like as small as 1. So we'll try this thing. Now let's move forward, and here I just want you to tell me a yes or no that I am writing the hypotenuse as root 5. Okay, so you'll be just telling me, can we take the base as 2? From school 1, the answer is yes or no. Can we take base as 2 just to complete this? P square plus B square, it is equal to H square. You are saying yes. Little bit energetic you have to be, because like I just want to hear your answers. Great. Okay, so from school 2, can you tell me that can I take the height or the perpendicular distance as 1? School 2, can you answer louder? Okay, so I'll tell you that how this happens. 2 whole square plus 1 whole square, that is equal to 4 plus 1, that is equal to 5. Now I have just solved the left hand side. Now 5 will be equal to h square and I get h as root 5. Now it is as easy as it is. Now you just have to put 2 units on the base like this. If this is 0, this is 1, this is 2. Now this will be our base up to 2 units. Now on this thing, we will have a perpendicular distance of 1 unit. Okay. Now when we join this is B point, this is O point, and this is A point. Now when we join OB, we get root 5 as hypotenuse. Now, if I open my compass and take OB as radius and put an arc on the number line, this OG will be equal to root 5 units. That is on the number line itself. Okay, that is on the number line itself. Okay, so I think you all understood this thing. So can you give me a thumbs up? Do you understand? Okay, school 2, little higher. Yes, I'm watching a whole bunch of class. Your little thumbs up, I cannot see them. Okay, so let's move on. Here what we have, representing root 9.3 on the number line. This is little bit different from the last one. Okay, so just follow the procedure. I think these questions do not have to happen in the examination, but we have to learn this thing. Okay, only once I have seen this type of question in the examination. So representing root 9.3 on number line, what we have to do is, we have to first, AB is 9.3 centimeter. Okay, if I'll say 9.3 units or 9.3 centimeter. Okay, as you can see, AB is 9.3. I just have to extend 1 centimeter further as BC. As you can see, BC is 1 centimeter. Okay, you just follow the steps. Okay, now in this thing, we'll be just following the steps for different questions. Now root 9.3, there is a decimal in the under root here. There is a decimal in the under root here. So what we have, I know this is a little boring concept, but we have to cover it. Okay, so you have to bear with me, and we'll be just covering, this is the last point, 9.3 under root, and we'll be focusing on the new concept. Okay, now AB, it is equal to 9.3, not root 9.3. Just focus on this thing. AB is equal to 9.3 and BC is equal to 1 unit. Now what we have to do you all know how to do the perpendicular bisector? Everyone from school 1, do you know how to do the perpendicular bisector? Yes ma'am or no? Okay, school 2, do you know how to do the perpendicular bisector of a distance of a AC?
Bisecting the
Okay, so what we do, we take the compass more than the half of the segment. Okay, and we put an arc on the upper side and on the lower side, putting on A. Our pointed end is on A. Now we put the pointed end on C and we put the arcs like this. Now when we join them, this is the O is the center point of AC. This is how we do the perpendicular bisector. Perpendicular it is, and it is bisecting the AC. As AO, it is equal to OC. Okay, AO, it is equal to OC. Now what we have to do, we have to take OA as the radius and we have to put a semicircle like this. As you can see here, we have taken OA as radius and we have drawn the semicircle here. We have drawn the semicircle here. So I'm just writing the shorter steps. So first of all, we draw AB as 9.3 units. Then we have extended AB to C. So we have BC as 1 unit. And after that, we have perpendicular bisector of AC. And after that, we have named that as O. Say O. And OA, it is equal to OC. And after that, we have taken OA as radius and draw semicircle. Draw semicircle. Okay, now after semicircle, we know where B stands. Okay, so from B, we just extended the line with the help of ruler. We extended the line, the perpendicular line from B. It will cut the semicircle at some point, say D. Cut the semicircle at a certain point, say D. Now, like I'll tell you that, like, hello, am I audible? Okay, like I told you, BD will be the root 9.3, the measurement root 9.3. Okay, so we will take BD as radius and put an arc on the number line. So taking BD as radius and put an arc on number line. So as you can see, this BC, this BE will be equal to root 9.3. I know this is little bit lengthy and boring. I also find it boring, but kindly bear with me. These are the steps we need to follow. Okay. So first of all, we have to draw AB that is equal to 9.3. That will be under the root. So if under the root will be 4.3, you will be plotting 4.3 on the number line. Okay. Now extend till C and BC will be equal to 1. After that, we have to do the perpendicular bisector. So this is the perpendicular bisector we have done. Now after that, we have just named that as O. Okay, we have just named that as O. OA is equal to OC because of the perpendicular bisector. Now OA is equal to radius and we have to draw a semicircle. We have to draw a semicircle. Now extend the perpendicular line from B like this with the help of a scale, and it will cut somewhere on the semicircle, say D. Now we have to take BD as radius and put an arc on the number line. Now this BD is equal to root 9.3 and on the number line that is equal to BE. So this is our final answer. This is our final answer. This is how we represent under root 9.3, which means a decimal number under the root on number line. So school 1, do you understand the concept? Yeah. Okay, we'll be moving further. Okay, this is a question for you guys. You have to answer me A, B, C, D. Let's see who will answer. These are the 4 options we have. Okay, somebody is okay. Can you answer? Yeah. Okay, you said A. Okay, school 1 has answered A as the answer. School 2? You just have to follow the Pythagoras theorem. H square, it is equal to P square plus B square. I need this to be root 17 whole square. So what will be the chances that what will be the P and B? So I am asking about the base. So you have to tell me the base. School 2, anyone? You're saying D. B, okay. So school 2 has answered B. So let me solve first. Okay, for root 17 to be the h, what will be the h square? It is 17. Okay, now you are guessing like 16 plus 1. Okay, you are guessing like 16 plus 1. But what will be the base? It will be 4 square, right? 1 square. It cannot be 16 itself. It is 4 because we are using the squares. We are using the squares. Let us see the answer. Okay, school 1 has answered correctly, and school 2, just I'll make you understand. On the this will be 4, this will be 1. Now putting in the Pythagoras theorem, perpendicular is 1, Base is 4. So we get 1 plus 16, that is equal to 17, and h is equal to root 17. Do you understand, school 2? Little louder. Okay. So I have to say it again and again, little louder. You have to be louder at once. So this is the question based on the last concept we did. Let's see now in real numbers what we are learning. Now in real numbers, let me tell you, you know a little bit about real numbers. So let me just go it through. Okay, go through this thing. All rational numbers can be written in the form of P by Q. You all know that. Where P and Q are integers and Q is non-zero. There are also some other numbers that cannot be written in the form of P by Q. You all know that. Where P and Q are integers and also are called irrational numbers. We cannot represent irrational numbers as P by Q, right? Now, if we represent all rational numbers and all irrational numbers and put these on the number line, would there be any point on the number line that is not covered? This is a question for you guys. I'm repeating. If I'll represent all the rational numbers and all the irrational numbers on the number line, would there be any point on the number line that is not covered? Yes or no? Okay, so school 2, can you answer? Is there any number left to represent apart from rational and irrational? School 2, can you answer? Okay, I think everybody is busy in writing the points. You will be getting this PPT. I'm not taking away from you. Can you answer, anyone? So the girl in the first line in school 2, can you answer? Just yes or no question. It is a yes or no question. Any answer, yes or no, you can answer.
No.
You are saying no. Great. So rational and irrational numbers. Apart from these numbers, we do not have any number left. So the answer here is no. Okay, so the answer here is no. So what does that mean? The definition of real number is it is the combination of all rational and all irrational numbers. It is a combination of all rational and irrational numbers. Let's see here. The collection of all rational and irrational numbers completely covers the number line. This combination makes a new collection called real numbers and denoted by R. Real numbers cover all the points on number line. I'm just making you remember that these are the same lines. These three are the same lines. We can say that every real number is represented by a unique point on the number line. Every point on the number line represents a unique real number. So we can say that, so we call this as the real number line. So do you remember we have number line? Okay. Now after the representation of real numbers, we can say that it is a real number line. So I think these all concepts, these all results regarding real numbers are understood. Can I move forward? What are you saying? Yes or no? Okay. So moving forward. Now revision of finding irrational numbers between two numbers. What was that? If I have A and B as two numbers, root AB will be my irrational number. If I just have to find one irrational number. And if I have to find more than one irrational number, I'll use the definition part. Okay, so I'm giving you a question, I think. Yes. Find any two irrational numbers between 1 by 5 and 2 by 7. Can you find me one only? You can convert this into decimal first. Okay, let me help you. So 1 by 5 is 0.20 and 2 by 7 is 0.285714 bar. I think now you can find two or you can find more then two irrational numbers in between these two numbers. Right? Now 0.2516924 is an irrational number between these two numbers. Say yes or no. Yes, it is an irrational number between these two numbers. Now 0.21692416. This is an irrational number between these two numbers. Yes or no? Yes. And some other number like this 46218. This is an irrational between these two numbers. Say yes or no. School 2, can you answer yes or no? Yes. So is this an irrational number between these two numbers? School 1, can you answer? Is this an irrational number between these two numbers? The answer is no. 2857. It is 2857. This is 2867. This is more than 2 by 7. It is not between. It is after 2 by 7 on the number line. Is that clear? So moving further, you have to find an irrational number between 3 and 4. Quickly, this is a quick question. Just put your hand up and you can answer. Let's see who will answer fast.
Amen.
Okay, somebody said A. Okay, school 1. Okay, school 2. School 2, anyone can answer. We have 3 and 4. We have to find an irrational number between them. You can answer combined. You can answer on the mic. Okay, you are also saying A, right? You are saying A? Okay. Okay, great. Okay, we have 3 and 4. So root AB will work. This is A, this is B. So root AB will work. What is root AB? It is 3 into 4. That is equal to root 12. So root 12 is the irrational number between 3 and 4. And this is the correct answer. Now, moving ahead, what we have? The only positive integer among the following numbers is. Let's see. Fast. Solve this question. You have a multiplication of two irrational numbers. Let's see. What is the answer of these multiplication? If somebody is done with the answer, you can raise your hand. You can answer loudly. Okay. A is the answer. Let's see. Yes, it's correct. Okay, here you can easily multiply 2 with this bracket and then root 3 with this bracket. But you can also apply that A minus B into A plus B. This is algebraic identity. A square minus B square. As you can see, A here is 2 and B here is root 3. Okay. So what will be A square minus B square? It is 2 square minus root 3 whole square. 4 minus 3, it is equal to 1. That is the only positive integer. In these two, we cannot get 1 as the answer or a positive integer as the answer. I hope you understood this thing and you can apply this algebraic identity to get a one-liner answer. Okay, moving ahead. Now we have our last topic, that is successive magnification. So with the topic name, you understood what successive magnification means. Now, we have seen that any real number has a decimal expansion. Now, first let us see how to represent terminating decimal on the number line. Here, we have to represent 2.776. Okay, I just ask you that does this number lie between 2 and 3? School 2, can you answer yes or no? Does this number lie between 2 and 3? School 2, can you answer? Boys from school 2 are really quiet. So 2.776, does this lie between 2 and 3? Yes or no? You're saying yes. You are fighting over the mic or avoiding the mic? So it is a yes. School 1, do you understood? 2 and 3, it is lying between 2 and 3, right? Okay. So if I have a number line like this, so what I get, this is 0, this is 1, this is 2, this is 3. I know that 2.776 lie between 2 and 3, but I do not know where. Okay. So I do not know where. So I'll magnify this area. I'll magnify this area. As you can see here, 2 and 3, we have 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9. Now, I have to see that where 2.776 will lie. So, let me give you two options. Does this lie between 2.6 and 2.7? Does this lie between 2.7 and 2.8? So, school 1, can you answer A or B?
B, madam.
Okay, great. B. Okay, so I have this window 2.7 and 2.8. I'll magnify this one. Okay, I will magnify this one. So what I have here, I have 2.7 and 2.8. Now I know that this number will definitely lie between 2.7 and 2.8, but I do not know where. So I'll again make little parts. 2.71, 2.72, 2.73, 2.74, 2.75, 2.76, 2.77, 2.78, 2.79. Now it will lie between 2.77 and 2.78, right? It will lie between 2.77 and 2.78. Now, when I draw that thing on the number line, like here, 2.77, 2.78. So this will be 2.771. This will be 2.772, 2.773, 2.774, 2.775, 2.776. This is my number, 2.776. I just found my number. So, first of all, it will lie between 2 and 3. Then after that, it will lie between 2.7 and 2.8. So, I'll magnify that area. Okay. So, after that, I'll magnify this area. This is here. Now, after that, I'll magnify this area, 2.77 and 2.78. It is here. So, here I found my number, that is 2.776. So, I hope you understood the process, that how this magnification works. You just have to find the immediate left and the immediate right where this number will lie. Understood, everyone? Okay, great. Okay, so here is another question. We have 3.58 bar. What does that mean? It is 3.5888 because we just want 4 decimal places. Will you be able to do this? It will lie between 3 and 4, right?
Yeah.
Then between 3.5 and 3.6. And further on, you can do this process, right?
Yeah.
Okay. Moving ahead, what we have here. Now, you have a question. Can you answer this? 9 over 11 is 0.81 bar. It will lie between. Anyone can answer loudly. This will look like 0.81, 81, 81 and so on. It will lie somewhere on the number line, but between what numbers? Can anyone answer? What happened? School 1, can you answer?
B, madam.
Okay, you are saying C because it is closely related in between this area. Okay. Now, is this a right answer? B, 0.8 and 0.9. It is also lying between 0.8 and 0.9. We are just moving reverse in the successive magnification, right? You are just saying the closest part, 0.81 and 0.82. That is correct. But it is also lying between 0.8 and 0.9. It is also lying between 0 and 1. So all these are correct. All these are correct. Okay. So between 0 and 1, then between 0.8 and 0.9. Okay. Then between this 0.81 and 0.82, in this area, this question, this number will lie 0.81, 81, 81 and so on. But it will lie between 0.81 and 0.82 and 0.8 and 0.9 and 0 and 1. So understood? D option is the correct option. Everyone? Okay. So I think last question is this. Real numbers are a combination of
Rational and irrational.
great. So rational and irrational. So real numbers are a combination of B and C. So what will be the option? A option. A is the correct option. So this is the class summary. We just learnt about the representation on number line that were root 2, root 3, root 9.3. And for real numbers, we have some definition and some results, right? And for successive magnification, we have literally used the successive magnification glass to express the numbers. And if you do not understand the lecture, you can have this recording, you can replay it again and again, and you can ask me in the next lecture also. So any doubts, anyone? You have a smile on your face after this lecture? Show me your hands. Okay. So do solve your worksheets and do solve the questions that you have. Thank you so much, and we'll meet in the next lecture.